I want you to close your eyes for a second. Seriously, just humor me. Imagine you hold the keys to a kingdom. It's not a kingdom of stone and mortar, it's a kingdom of data. You are responsible for the entire financial history of a massive company. Every transaction, every dollar, every single decimal point, it's all on your servers. And because you're good at your job, no, because you are obsessed with your job. You have a perfect backup plan. You have contingency plans for your contingency plans. You sleep soundly because you know that no matter what happens, fire, flood, hackers, you can always hit undo.
It's the ultimate safety net. It really is. It's that feeling of invincibility where you think, I am the master of time. I can just rewind.
Exactly. Now open your eyes. Imagine the worst happens. A catastrophe hits the database. You calmly walk to your terminal, you crack your knuckles, and you hit that undo button. And the system, it just laughs at you. The backup isn't there. The safety net has a hole exactly the size of the disaster you're falling through.
That is a terrifying thought. For a database administrator or a DBA, that is the literal definition of a nightmare. It's the kind of thing that makes you wake up in a cold sweat. But for the subject of our deep dive today, it wasn't a dream. It was a Tuesday.
Today, we are doing a deep dive into the case of Sueza Enterprise. And, when I first grabbed the source material for this, I thought we were looking at a pretty standard technical postmortem. You know the type. Server failed, here's the patch we applied, everyone is happy. But this is not that. This starts as a database crisis, and it spirals into a full-blown corporate thriller.
It really does. We're calling this one the unrecoverable hour, but it's more than that. It's a story about what happens when digital forensics uncovers things that were, well, probably meant to stay buried. We're looking at how data recovery actually works when the systems we trust completely fail, and the darker side of what you might find in the debris.
So let's introduce our protagonist to set the stage. Her name is Elena Costa. She's a senior DBA at Sueza Enterprise, and the sources describe her as a zealot for backup hygiene. I absolutely love that description.
It paints quite a picture, doesn't it? She had this mantra she would tell her junior engineers: data loss is a choice. She wasn't just doing her job, she was like evangelizing a philosophy. She ran a PostgreSQL environment.
That's a very popular, robust, open source database, right? Used by a huge company.
Exactly. And she had set up something called continuous archiving.
Okay, let's unpack that term for a second because it's really central to why this all went so wrong. Continuous archiving. How is that different from just, saving a copy of the files every night?
Well, think of a standard backup like taking a photograph of your data once a day, say at midnight. If you lose data at 5:00 p.m. the next day, but your last photo was from the previous midnight, you've lost 17 hours of history. You're completely blind to everything that happened in between.
I see.
Continuous archiving is different. It's like a security camera video feed.
So it's recording constantly.
Exactly. In PostgreSQL, every single change, every insert, update, delete is written to a log file first. This is called the write-ahead log, or WAL. Elena's system was set up to constantly ship these log files to a secure, separate storage server. Theoretically, this allows for what's called point-in-time recovery. You can pick any second in history and rewind the database to that exact moment.
So she's bulletproof. She's got the snapshots, she's got the video feed, she tests it routinely. Her team probably called her paranoid, but she called herself prepared. Enter the antagonist. Or maybe just the catalyst.
The catalyst, for sure. March 15th, 2:17 in the morning, a junior DevOps engineer named Mark.
It's always a Mark, isn't it? Or a Dave. And it's always 2 in the morning. Sorry to any Marks listening.
So Mark runs a script, migration v2.1 fixcodes.sql. Now, to be fair to Mark, the script was supposed to be a tiny cleanup. It was meant to fix 12 test records, just 12 lines in a database of millions. But Mark missed a schema prefix.
Okay, hold on. Schema prefix. That sounds technical, but it's the smoking gun here. What does that actually mean?
Think of your computer. You have folders, right?
Yeah.
If you tell the computer delete the file named report, but you don't tell it which folder to look in, the computer might just look in your default folder, which could be your desktop, where you keep all the important stuff.
Oh, I see. So a schema is like a folder for data.
Exactly. Mark thought he was running this fix in his personal test folder, but because he didn't specify the prefix, the script defaulted to the public folder, the production environment.
Ow.
And because of some really complex cascading triggers, basically automated domino effects that nobody fully understood at that hour, the script didn't just touch 12 records. It touched 412,887 legitimate transaction codes. And it turned them all to NL.
NL. Just blank.
Gone. Void. In database terms, NL doesn't mean zero. Zero is a value. NLL means unknown. It effectively wiped the identity of nearly 500,000 financial transactions.
But here's the kicker, and this is why we call it the silent plague. The database didn't crash, did it?
No, and that's the worst part. Technically, the command was valid. The database did exactly what it was told to do. It successfully executed the update. So no error lights blinked, no pagers went off. The system thought it was operating perfectly.
That is the part that just chills me. Because if the server explodes, you know immediately. You wake up, you fix it. But
Yeah.
this is so insidious.
Precisely. The corrupted data started spreading. For 6 days, these NOL values flowed into reports, they went out into APIs, they ended up in financial statements. It's like a virus spreading through the bloodstream, but the patient looks totally fine.
Until they don't.
Right. The realization didn't come from a monitoring alert. It came from a panic attack. The CFO calls Elena screaming that the Q1 report is gibberish and money is just disappearing.
So this is Elena's moment. This is what she trained for. This is why she's the zealot. She has her point-in-time recovery. She knows exactly when the script ran 2:07 a.m. on March 15th.
Yeah.
So logically, she just needs to rewind to March 14th at, say, 23.59.59,
Or
1 minute before the chaos.
on paper, yes. She initiates the recovery sequence. The system starts humming. She's watching the logs scroll by, feeling that rush of, I'm about to save the day. And then, silence.
The failure.
The error message was so cryptic, it just said, requested timeline does not contain the requested recovery target point.
Which translates to,
The time you were looking for does not exist.
Elena discovers a gap. A literal gap in the history. The specific write-ahead log segment, the file containing the data for that specific hour, was missing from the archive.
How is that even possible? She's the zealot. She checks this stuff.
It's a cruel irony. The root cause, or what looks like the root cause, was in her own backup script. It looked like a race condition.
Break that down. What's a race condition? A race condition is when two processes compete to do something at the same time, and the outcome depends entirely on who wins the race. Under normal loads, her script worked fine. But Mark's massive accidental update generated a huge amount of data in a split second. The archiver script tried to upload the log file at the exact same moment the database was still aggressively writing to it. The script got locked out, failed silently, and just skipped that one segment.
So the very event that destroyed the data
Also broke the backup that was supposed to fix it.
Wow. The perfect system failed at the one moment it was desperately needed.
Exactly.
So now she's staring at a screen. The CFO is probably hyperventilating on the other line, and the undo button is broken. This is where the deep dive really shifts gears. Because Elena doesn't give up. She pivots.
This is the part of the story I find most fascinating. She stops trying to recover the database, the container, and starts trying to recover the contents. She basically becomes a digital forensic investigator.
Sherlock Holmes with a command line.
You could say that. She launches this multi-vector recovery. Phase 1, wall fragment mining. Even though the main segment was missing, she knew that data leaves fingerprints. She used these low-level tools to scour the hard drives for before and after images that might be lingering in other log fragments or temporary memory dumps.
It's like finding a shredded document, but maybe you have a few strips left over in the bin.
Right, but that wasn't enough. So she moves to phase 2, the application echo chamber. She realized that the database isn't an island. It talks to other things.
Oh, I see. So if the database says NLL, maybe the email confirmation that went out to the customer says transaction 12345.
Precisely. They looked at application logs, external payment gateway records, cached web pages. They treated every external system as a witness to the truth. They called it digital exhaust.
I love that term, collecting the exhaust to figure out what kind of car drove by.
And for the gaps that still remained, they went to phase 3, pattern reconstruction. They built a probabilistic model. They analyzed the uncorrupted transactions, time of day, amount, department, and used that to infer what the missing codes probably were.
That sounds a little risky, guessing financial data.
It is risky, but when your alternative is NUL, a high probability inference is better than nothing. And it worked. After 72 hours of hell, they recovered 99.1% of the data.
That is an A-plus effort, 99.1%. Most people would take a victory lap, pop the champagne, and go to sleep for a week.
And if Elena had done that, we wouldn't be talking about this case today, because it's the 0.9% that changes everything.
The anomaly.
There were 3,716 transactions that didn't be reconstructed. And when Elena looked closer, she realized they weren't just random errors. They followed a very specific pattern.
What kind of better?
First, the amount. Every single one was for exactly $499,999.99.
Just 1 penny under $500,000. Why is that specific number important?
Well, in many corporate governance structures and banking regulations in general, $500,000 is often the threshold for automatic board review or external auditing triggers.
Ah, so if you keep it 1 cent under, you fly into the radar.
Exactly. It's a technique called structuring, or sometimes smurfing, breaking large amounts of money into smaller chunks to avoid detection. That immediately signals intent.
Okay, that's immediately suspicious.
Second, they all involve the same three offshore entities. And third, and this is the technical smoking gun, they all referenced a timeline 7.
Timeline 7. Wait, remind me how PostgreSQL timelines work.
When you restore a database or make a huge structural change, you often create a new timeline of history. It's like a fork in the road. Elena's official archives only went up to timeline 4. Timeline 7 shouldn't even exist. It's like finding a receipt dated from a parallel universe that you never visited.
So where did this ghost timeline come from?
She went hunting. She found encrypted wall segments hidden on a forgotten staging server, a server that wasn't supposed to be part of the production loop at all. When she decrypted them, she found the truth. These corrupted transactions. The ones Mark's script supposedly ruined, they weren't ruined, they were replaced.
Explain that. What do you mean replaced?
The NOL values weren't an accident, they were a cover-up. Someone had injected these shadow transactions, these $499,999.99 transfers, onto a secret timeline fork. And then they likely triggered Mark's accident, or at least exploited the confusion to hide their tracks.
So the missing backup segment, the so-called race condition.
It wasn't a race condition, it was sabotage. Someone physically deleted that hour of history to hide the point where the timeline forked.
This gives me goosebumps. So Mark, the junior engineer who ran the bad script, was he just a patsy? Or was he in on it?
Well, this is where the ghost in the machine enters the story. While Elena is staring at this impossible Timeline 7 data, a message pops up. Not in her email, not on Slack. It appears directly in her PostgreSQL log monitor.
Someone is writing into the database logs to talk to her. That's incredibly invasive. That means they're inside the system right now.
It's a display of total control. The message was signed Ghost in the Machine, it said. The missing wall segment isn't lost. It was removed. Timeline 7 is the real ledger. What you recovered is the cover story. And then it ended with a warning. They know you're close. What? Be careful what you recover.
That is straight out of a movie. They know you're close.
And it gave her a clue. It pointed her to Mark's last commit message. Remember, Mark had resigned immediately after the incident.
Vanished into the ether.
His last code commit message was fixing schema reference issue, but embedded in that message was a hash. When Elena decoded it, it spelled out check archive server 3.
Server 3.
A server that was supposed to have been decommissioned months ago. Dead hardware. But when she pinged it, it answered. It was online.
So we have a phantom server, a ghost timeline, and nearly 4,000 fraudulent transactions totaling. Quick math. Nearly $1.8 billion.
Roughly, yes. High stakes. But here's the real bind Elena finds herself in. She has successfully restored the database to management satisfaction using her reconstruction method. The company's running, the CFO is happy, but she knows that the restored database is a complete lie. The real history Timeline 7 proves massive financial crime.
She's holding a grenade. If she reveals Timeline 7, she crashes the company and exposes the crime, but she also admits her own recovery was fake. If she stays silent, she's an accessory to a billion-dollar theft.
And the source material ends on a truly chilling note. She's sitting there paralyzed by this decision, and suddenly her screen refreshes. A new wall segment starts streaming to her local machine.
Streaming? From where?
From inside the network. But the header says it's from Timeline 7, the criminal timeline, and the first line of the transaction log isn't a financial transfer. It reads, begin transaction, Elena access log.
Oh my God.
Wow.
They aren't hiding their transactions anymore. They are logging hers.
That is terrifying. It implies they're watching her watch them. It implies total compromise. And just think about the legal implication of that.
Right. If she goes to the authorities now.
Exactly. She has the stolen data on her own machine. The logs now show her accessing it, decrypting it, interacting with it. The ghost is creating a paper trail that makes Elena look like the architect of the whole scheme, not the investigator.
It's the ultimate trap. Timeline 7 becomes her timeline.
It's weaponized forensics. They are betting that she won't blow the whistle because all the evidence now points directly to her.
So what does this all mean for us, for you, listening? Because this started as a story about backup scripts and schema prefixes.
It's a stark reminder that in the digital world, data is never just neutral zeros and ones, it's evidence. We tend to think of glitches or corruptions as accidents, entropy, cosmic rays, bad code. But sometimes a glitch is a feature. Sometimes chaos is manufactured to hide order.
It makes you question every system error you've ever seen. Was it really an error, or was it a smokescreen?
And for the tech professionals listening, looking at logs isn't just debugging, it's archaeology. You're digging for the truth. Elena thought she was just fixing a database, but she was actually unearthing a crime scene. And once you touch the evidence, you are part of the story.
You know, it leaves us with this massive hanging question. The source material stops there. We don't know what Elena did next. But I can't help but wonder about that final log entry. Elena access log.
It's the ultimate checkmate.
I'm going to be thinking about timeline 7 every time I do a backup from now on.
Thank you for listening to this deep dive into the Sueza Enterprise crisis. It's a reminder that sometimes the things we lose are lost for a reason, and finding them might just be the most dangerous thing we can do.
Stay curious, but maybe. Check your log files. And see who's watching back.
We'll see you on the next deep dive.